Hello everyone, I'm Alice Yan-En-Shi from TCM1. Today, I'll be introducing the topic that we choose, which is the linear motion and force.
Linear motion and force. In this topic, it will conclude linear motion, freeform motion, projectile motion, Newton's laws of motion, frictional forces, linear momentum and collision, and equilibrium of particles.
The appendix that we use is a rough surface table, a smooth pulley, a 2 kg box, a 3 kg box, a smooth surface, and an inclined plane. Let's look at the 2 kg box that will move to the direction right. So, W will be smaller than the force. Then, the 3 kg box will act downward. The W will be bigger than the F. Now, I will pass to the next person to explain the solution of this question.
My name is Talisha, and now I'm going to explain about this question. So the first question is, calculate the weight of the 3 kg box and the resultant force of this system. First, the system has a 3 kg box attached to a pulley, and there is a horizontal force of 2 kg which opposes the downward weight of the box. So, to calculate the weight of the 3 kg box and the resultant force of this system, we need to find the weight of the 3 kg box, which we use the formula W equals mg, where m is 3 and g is gravitational force, which is 9.81. So we use 3 times 9.81 equals 29.43 Newton. And for the resultant force, since the system experiences a horizontal which opposes the force of 2 Newton, and the formula for resultant force is weight minus opponent force. We know that our weight is 29.43 Newton, and we minus the opponent force, which is 2 Newton. So we get the answer, which is 27.43 N, which is our resultant force.
Hi, my name is Lewin Kim Nan. Let's start the section B of this question. If we add a smooth surface on the table, what is the acceleration of the 2 kg box? Hence, find the tension of the rope. First of all, let's mark the 2 kg box as A box and 3 kg box as B box. The total force is equal to the weight of the 3 kg box, which is B box, minus the tension force of the rope. While the tension force of the rope, F1, is equal to the mass of A box multiplied by the acceleration. Because the pulley is used in this experiment, therefore, the tension force in part A is equal to the tension force in part B. By this information, we can build two equations. The first equation is the total force is equal to the mass of B box multiplied by the acceleration. The second equation is the total force is equal to the mass of B box multiplied by the gravitational acceleration and minus the mass of A box multiplied by the acceleration. Now, combine these two equations. Then we get a new equation. Mass of B box multiplied by acceleration is equal to mass of B box multiplied by gravitational acceleration and minus the mass of A box multiplied by acceleration. Mass of B box is 3 kg, so we write it as 3A. And in the right hand side, the gravitational acceleration is 9.81. So we write it as 3 multiplied 9.81. And mass of the A box is 2 kg, so we write it as 2A. And after a process of calculation, we can get the value of acceleration. Now, we know that the acceleration of this process is 5.886 meters per second square. Hence, find the tension of the rope. The tension of the rope is the mass of A box multiplied by acceleration. mass of a box is 2 kg and multiply with the acceleration, which is 5.886 meter per second square. Finally, we find the tension of the rope, which is 11.77 Newton.
Hello, my name is Tan Yuan Lam. Now I will be discussing the third question. We can take a look at this diagram. We can notice that there will be mass times gravitational force and normal force acting on both 3 kg and 2 kg box. The normal force of both boxes are not the same. Tension of 2 kg box will act toward the right, while 3 kg box will act toward left. The inclined plane consists of 45 degrees. If we add an inclined plane beside the table, move the 3 kg box on the inclined plane, and there is no friction between the surface and the block. What is the acceleration of the system? For the solution of this question, we can use the formula of force equal to mass times acceleration. The force is known as tension. We can label this equation as 1. The formula that we will be using the 3 kg box is weight minus tension equal to mass times acceleration. Then, we will be labeling this equation as 2. Weight equal to mg sin theta. Let the equation 2 plus equation 1. Mg sin theta minus ma equal to ma. Next, mg sin theta equal ma plus ma. We can simplify the equation by putting brackets that covers m plus m, then times a. Then, we allocate a to the front and equal mg sin theta divide m plus m. Value will be then sub into the equation, and we will be obtain 3 times 9.81 times sine 45 degree, and divide by 2 plus 3. The final answer we will be getting is 4.162 meter per second per second. That's all solution from us. Thank you for viewing our video. Thanks.